All right, we'll go ahead and get started. You're in hardening AWS environments and automating incident response. I'm Andrew Krug, and this is Alex McCormick. Before we get started, we're super excited, like to be here at DerbyCon. I have been trying to come to DerbyCon for probably 3 or 4 years, and I haven't been able to get a ticket. So now I'm convinced the best way to secure a ticket is just to create a software project and present it at DerbyCon. So we're a really small team of people that work on this tool suite called Threat Response that we released earlier this year at Black Hat. There's only 4 of us, and we're looking for other people to join us as contributors. So if you're interested, please do talk to us. We are not a product or a corporation. Absolutely nobody pays us to make security software for Amazon. And everything that we're going to talk about today is totally free open source software that you can go and get right now. We all do have real day jobs, though. We can't say where because of weird corporate policies. Yeah. If you do find out where we do work, which is not hard at all, because there's things like LinkedIn, these are not the opinions of our employer, of course. You can totally get the slides for the presentation right now. The URLs, though, are wrong in this deck, so we tweeted them. Hashtag DerbyCon for this talk. So if you want those, all the links are in the slides, and they have been published. So here's the agenda for today. This is you, right?
Yeah. So today's agenda, we got 4 main parts. We're going to talk a little bit about the inspirations for how we started looking at incident response within AWS. So we're going to cover some blog posts and some Black Hat videos. So then we're going to cover actual incident response within AWS, introduce the tools that we developed. We're going to talk about advanced attacks and defenses in AWS, and then we'll wrap everything up with final tips and resources. So let's start with actually looking back past year in AWS security. There's a lot of significant blog posts that influence us. And just to reiterate, these are all links, so get the slide deck, you can follow the links, you can go read these blog posts yourself. Daniel Grzelak did a lot of offensive stuff. So assuming you get an AWS key, what can you then do with that key to disrupt other people's Amazon accounts? Tony De La Fuente published a forensics in AWS article, which really inspired our AWS IR tool. And then Eric Hammond has a really cool blog post about how the read-only IAM access management policy is a little too permissive and can allow some bad things to happen.
And then what we sort of saw during the summer was we saw those blog articles boiled down into security research, like legitimate techniques for persisting long-term in AWS accounts, which is sort of the first time that we've really seen on stage people do things besides just mine bitcoins with compromised keys. So there was this paper that was put out, Account Jumping, Post-Infection Persistence, and Lateral Movement, which we're going to get to a little bit later in the talk. There was this great talk by Loic Simon called Access Keys Will Kill You Before You Kill the Password, which is all about how we don't seem to be learning from the mistakes that we made with passwords. We're still inventing new systems and storing plain text credentials on disk, which is how your AWS keys get stored. And then there was this talk, which you're in a version of now.
So we went through that section very quickly. We're going to do the incident response within AWS section. It's the most meaty section. We've got 5 parts. We modeled it after the 5 stages of incident response. So we're going to have some coverage of preparation, identification, containment, eradication, and recovery. But we're not going to talk about recovery. That's going to be specific to your organization, so you can figure that out on your own. So let's talk about preparation. So just real quickly, I wanted to point out AWS just updated a new best practices guide. That was released in August, so you can go download that. It's a full 70 or 80 pages of best practices for hardening and setting up your AWS accounts. The CIS, Center for Information Security, also has their foundations benchmarks. So if you're in the mood for checklists, that's a document you may want to use. It's a great checklist. It's good things to look for. And if you're doing an audit or something where you want someone else's guidelines that you can use, that's a good place to start. And also develop an incident response plan. Lastly, in terms of things to get ready, I just wanted to point out, if you're familiar with the Awesome projects, like Awesome Ruby or Awesome Node, there's a Awesome Incident Response page, and it lists a bunch of incident response tools. So if you don't know about it and you're kind of in the mood of like, I kind of want to know about some more tools, go check out this GitHub page. It's got lots of tools. It'll tell you a little bit about them, and then you can go to the actual tool page itself to download it. And then while looking at that, I found Awesome Search, which is another website that shows you just awesome lists. And so you can find all of those related to security, which will have things on like malware exploitation or even car hacking. So now that we've talked a little bit about kind of getting your environment ready, let's talk about hardening it, like actually implementing the things that we read about in the last section. So we're going to cover, real quickly, we're going to cover about 6 tools that you can use. They all have their own strengths and weaknesses. So let's take a quick look at best practices auditing. So if you've used AWS, you're probably familiar with Trusted Advisor. If you have a business or an enterprise support plan, you're probably familiar with it a little bit more. It's kind of restricted to those users. It's going to give you basic cost optimization, security rules, things that you can do. It's very simple. It's very basic. There's no programming against it. You can't find out, like, alert me when something bad happens. It's just in the dashboard. It shows up as the red box. So the best thing it has going for is it's very, like, C-suite friendly. You can, like, print it out with no red marks and be like, hello, executive, like, I'm compliant, and then they're happy. But the checks aren't that comprehensive. Config and config rules are much more comprehensive. These are actually 2 kind of separate services. So AWS config is really great. It's a logging service that deals with the configuration of a particular AWS resource. So if you create a EC2 instance, that gets logged, and all the state information of that EC2 instance gets logged as well. So what VPCs is it attached to? Which disks are it attached to? All those things, anytime a resource is created, updated, or deleted, those all get logged. So you get this fantastic historical record. You can answer questions like, when did Joe have access to this specific resource? You can go look through your config lists, figure out which policies applied to him, and figure out when he actually had access to a resource. Config rules is the ability to actually do things about those configuration items. So you can put logic in there to say, if a EC2 instance is created, but that EC2 instance is attached to a VPC that is wide open to the world, then we're going to report back to the users. So you get a lot more granularity in terms of what you're looking at with config rules. Amazon defines some config rules for you, and you can also write your own. There's also another tool called Prowler. Prowler was written by Tony De La Fuente. It uses those Center for Information Security benchmarks, all of their checks. It's a single bash script, but it checks for all those checklists. So if you have a client who wants you to evaluate whether or not they're compliant within those standards, here's one script you can run. It's very simple to set up. You hit run, and it'll give you a yes or no on all those checks. Getting a little bit more sophisticated is Scout 2. This is sophisticated in terms of the fact that you can add your own logic to it, and it's more than one file. It's written in Python, but it's very easy to set up. It's 2 commands. You install the requirements, and then you run the program. It generates a static HTML page that you can click through and get the results of your actual analysis. It has roughly 63 checks right now, and you can always add your own. I really liked Scout 2. I'd encourage everyone to check it out. Open source, and it's written by NCC Group. Next, going up further in the complexity scale, we have Cloud Custodian. Cloud Custodian is a policy generator. So in that sense, it's a little closer to config and config rules. It's evaluating actions in your AWS environment. It's stateless. So just like all the other tools we talked about, you run it once, you get your results back, and it's up to you to throw that in a cron job and check the results kind of thing. It's very easy to use. It's written by Capital One. The highest in terms of complexity is SecurityMonkey. This is a stateful piece of infrastructure that you set up yourself. SecurityMonkey kind of did a lot of the things that Amazon took over with CloudTrail and CloudWatch and Config, they had it in SecurityMonkey before Amazon was really even kind of looking at it. SecurityMonkey, even though you have to set it up yourself and it takes a little bit more, gusto to get going, it can really pay off if that's the kind of granularity you need. So which tool should you use? And the obvious answer to that question is whatever is best for your environment. So would highly encourage you, if you don't have something doing compliance checking already, start with something simple, maybe Scout 2 or Prowler. Just throw that in throw it in a cron job and have it send you an email every time you get alerts, every time, configuration fails. And then as your demands and your complexity of your project increase, then you can move on to more complex projects. So that was the best practices auditing. Let's move on to specifically auditing IAM user and policy instances. So the difference between the section we just talked about is when we talk about auditing users and policies, we're specifically looking at that one best practice of least privilege. Everything that we're going to talk about in terms of attacks with AWS access keys, they're all irrelevant if you can successfully implement least privilege. And so the reason why companies or organizations have giant problems with, spinning up Bitcoin miners or acts like shutting down, live instances of production is because someone made an account that was too privileged and leaked those keys somewhere. So the first step when you're trying to evaluate a policy or a user is to use Access Advisor. Access Advisor is all right. It's similar to Trusted Advisor. It's only in the IAM web console. You can't program against it, but you get access to a list of services for a particular user or a particular policy that is allowed by that policy. And then you get whether or not that service was ever accessed by a user using that policy. So you get to see very easily whether or not you need to let somebody have permission to something. If they've never had a reason to use, say, Route 53, then you can remove those permissions from their policy. But again, it's programmatable. You can't, so you can't write an API against it, you can't alert about it. It's kind of best for kind of spot checking people's user accounts. It's also only at the service level. It's not at the API level. So, for example, EC2, people might always be spinning up instances, but you don't know if they're actually terminating instances. So do they actually need to have that terminate instance permission allowed? And so if you want to do that, there's a link up here. It'll run through a little bit more of the details, but you can actually use CloudTrail. So if you don't know CloudTrail, CloudTrail logs all interactions you have with Amazon AWS, so whether it's through the web console or through the SDK, Bodo, that kind of thing, that all gets logged in CloudTrail once you have that set up. You can then pull down those CloudTrail files from an S3 bucket, and then in this example, I just queried it with a tool called JQ and just grabbed every action and every service that my particular user used. And then I just built a policy around that. If this is all they ever do, just give them permissions to just do that. There's another video you should check out. AWS just put out a talk about this last year. And it kind of walks you through how to use some of the other IAM tuning services. And lastly, when we talk about preparation, we really want to encourage you to practice. Have IR game days or security simulations. The caveat here is you need to tell AWS about this before you do it, but we simulate with red teams all the time when we're actually breaking into applications. But whether or not you are doing it with AWS is a whole other story. You need to start thinking about what if an attacker got one of my compromised keys, what are the things that they could do? You want to cover identification.
Yeah, so now we're going to talk about identification, like how do you know when you have been breached? One of the great ways to do that is just by auditing CloudTrail. Of course, if you have a really savvy attacker, they're probably going to disrupt logging, and that in and of itself is an artifact that you've been compromised. You can do that with CloudWatch metrics. CloudWatch metrics and CloudWatch events, which people actually don't know that much about, I find, because CloudWatch is just kind of one brand, and then they buried this nice events button with the tiniest orange text that just says new. And like, how are you supposed to even find that? CloudWatch events are great, though, because they alert really, really fast. Config rules take in all of the information about all the states of items in your account. So it can take up to 4 minutes for a configuration item to kick off an alert, where CloudWatch is going to notify you in probably 90 seconds or less that something's gone wrong. So you have much less time that an attacker is persisting in your account if you use CloudWatch events to create alarms. So there's a great AWS CloudFormation template that you can pretty much just run in your account that will turn on security events in CloudTrail. This is really great for anomalous things that we always want to be notified about, like root account logins. If somebody ever logs in with a AWS root account, you want a notification to go out to your team, and everybody drops what they're doing and starts responding. So you can apply that, and there's a link in the slides. I'm also talking about containment, right? Okay. We so practice, but we wanted to make the slides a little bit more fun for this audience, and we have 100% more hacks than we had at Black Hat, so it's much more exciting. So we built a command line tool as part of the threat response project called AWS IR. I know it's not a very exciting name, but it does what it says, which is that you can use it to process a compromised host in your account, so something that gets hacked, like just an app, or a key compromise, like I've leaked a key onto the internet and now I need to do all the right due diligence things to mitigate that inside of my account. So it's a really simple command. It installs via pip in Python. I think we're even so real that we're in PyPy now. Like you don't have to just install from source, we're in PyPy. So you can just run this one command and give it the IP address, a username, and an SSH key, and then it'll do all the things that it needs to do to contain that instance. Including shifting it into an isolate security group, preventing outbound access, taking disk snapshots, and also taking memory from that instance. If you have a key compromise, we'll disable the key, and we're currently in the process of adding features that mitigate temporary session token attacks, which we're going to talk about how scary session token attacks can be in just a tiny bit. So often what we also see, though, is that host compromise can lead to key compromise. So if you pop a box that has an IAM role associated with it as an attacker, sometimes you can use that to escalate to having some temporary session tokens or keys. Has anybody ever heard of the metadata service in AWS? Yeah, it's a nice feature for developers because you can just curl this URL 169.254.169.254/latest/metadata. And from there, if the instance is running in a role, you can actually query the roles, and it'll say, here's the role of this instance. And then if you know the name of the role, you can go from the role to creds. So this is curlable as root and non-root in the instance, right? So as an attacker for me, this is like winning, because now I have those STS tokens, which are valid on any other box I want to use them on for about 15 minutes. And so I can just keep asking for those for as long as I have access to the instance. So what, though? Like, I have those creds. As a defender, you can protect against this with an IP tables rule, and you can at least prevent non-privileged users from getting to that binding if you don't actually need this for an app to do what it does. So go ahead and throw that in your default AMI builds. So when key compromise, key compromise can also be the other way around. Like, key compromise can lead to host compromise, where if somebody has an access key for your account, they can snapshot a disk, spin up a new instance, attach that snapshot, dump Etsy password, crack passwords, also win. So it can work the other way around as well. Is eradication mine too? No, that's you. We live in different time zones, so it's hard for us to rehearse.
So we're going to show, we talked about AWS IR and how it deals with isolation. So actually isolating your compromised host. Eradication, we decided to take a different approach. We decided to look specifically at the forensics of trying to figure out what happened. How do you even know you eradicated something until you've done your actual investigation? So the rest of the eradication section, we're going to talk about collecting evidence and actually being able to examine that evidence with AWS IR. So I'm going to this is running really fast. Don't worry about what it's saying. Just note that lots of things are happening And that's what we should be excited about.
This is the tool running. Like you can try this at home. In fact, we encourage you to try it at home.
And it's also running at 5 times speed, just so we don't have to wait. But what it's doing is it's grabbing a bunch of it, so it isolates the instance, then it grabs all this data, throws that in an S3 bucket, and then gives you this command to run to launch what we call our threat response workstation, which is an analysis AMI that you can run inside Amazon. So let's start talking about which data we want to collect. So we collect AWS data, disk, memory, and network. Those are the core elements you're going to want to collect when you're starting your investigation. Throw all of that into an S3 bucket. In terms of AWS data, there's a lot of features within, so we use Boto 3 for AWS IR. There's a lot of features in the Amazon SDK to get even more information about an instance. So we grab EC2 console output, the screenshot of the console if it happens to have a GUI, AWS specific metadata, so similar to things that would be in config if you had that set up, which devices are attached, which network devices are attached, the IP addresses of those, the AMI ID, so you know what your base image was. And then also you're going to want to collect relevant CloudTrail logs. We're working on that feature now with AWS IR. So when AWS IR runs, it's going to take a snapshot of every disk associated with a compromised host and store that within Amazon. But then how do you analyze it? So we decided to add a little workflow to make it easier for people to analyze it with inside AWS. So after you run AWS IR host compromise, you can create a workstation. And when you create the workstation, you get this nice web UI that lists all of the disks that were created. You can then click a button, and what will happen is that disk gets processed with log to timeline, generates a Plaso file. That Plaso file gets dropped in S3, and then you can use a Google tool called TimeSketch to analyze that Plaso file. Is anyone here familiar with TimeSketch? A couple people? Yeah. So it's a Google project, but they don't like calling it. It's not a project by Google. It's just code that happens to be owned by Google. So like we're going to pretend that they still think it's cool because we think it's cool. This is an example of what it is. It's a log viewer, but it's meant to be collaborative. You can have multiple people log in, comment on events that you see. So we think it's a pretty good way to analyze a disk. All this happens with 2 clicks from the user. There is no setting up log to timeline. There is no setting up like trying to import your own Plaso stuff. It's all done for you. So you did disk, you went through all those events and you found all the bad things. What about memory? So memory, we're really excited about. One of our team members, Joel Ferrier, wrote this awesome tool called Margarita Shotgun. It's completely standalone. If you don't want to use AWS IR, you can use Margarita Shotgun on your own. But what Margarita Shotgun does is, people familiar with Lime, like memory acquisition with Lime. So the thing about Lime is you got to have those kernel modules pre-built, and there's a lot of piping stuff over the network, and maybe that's in the clear. So Margarita Shotgun wraps all of that. We pre-compile most of the Amazon certified AMIs. If you try to use it and you don't find a kernel module that you need, just ping us and we'll spin one up for you. And even more so, we give you the ability to use your own warehouse of kernel modules if you happen to not trust what we build for you. But it's going to, so Margarita Shotgun will SSH into a compromised host, figure out the kernel, grab the Lime kernel module for that particular host, grab memory, securely copy it over the network, and then drop it in an S3 bucket. It can do this all in parallel, very low overhead. It's a really nice tool. Once it's in the S3 bucket, you can use the threat response workstation to actually view it with volatility inside your web browser. So you don't have to pull down that several gigabyte memory data dump. You can just do it with volatility with tools you know.
The volatility instance is a Docker container, so each memory sample is like totally isolated in its own environment. So, Docker security.
There's a lot of Docker stuff going on here, yeah. All right, network. We don't collect network data. You have to have VPC flow logs turned on. It's in a to-do list. We will grab that if it's available. But you might get some network information from memory, so make sure you check out the memory section. All right, so in conclusion of the AWS with IR section, covered a lot of preparation tools, our 3 threat response tools. If there's any takeaways from this, it's make sure you customize your response to whatever your organization is, right? Practice using any of our tools that you want to use. If you find they don't do what you want them to do, feel free to just cherry pick the parts you like, just take the code. It's MIT licensed, all you have to do is put the little copyright header there, and you're good to go.
All right, so this is where we get to the hacks and stuff, which is what you really want to see, right? So if you want to make something for the AWS security ecosystem, by the way, like you can just take any word about a cloud, an action, or a place, and an optional thing to operate on, and you can make product Mad Libs for the AWS team. Yay, I got some laughs. So I have, from our small batch print, 2 threat response t-shirts, which are our very first t-shirts that I have paid for this to give away for people who can answer my trivia questions. And you will have your choice of a fabulous large or a fabulous small, because I never get small t-shirts at security conferences, so I will give you a choice. So I have these. So who said defense without offense is just compliance? Just shout it out. No. Anybody? The slides are on the internet.
You guys should the answers in the next slide.
It was Dan Kaminsky, so I will reserve 1 t-shirt for the person who asked the least inane question at the end of the presentation. But I love this. I love this talk because Dan Kaminsky says that we keep making the same mistakes over and over in security, and that we aren't learning, so we can be better defenders by learning to be attackers. And so let's talk about how you would model these advanced attacks in your environment: logging disruption, security token service persistence, and my new super cool backdoor toolkit that I'm going to release today here at DerbyCon.
He's so proud of it.
I'm not that proud of it, but I don't think anybody's ever done it. So being first is worth something, even if it sucks. So ground rules, non-boring material ahead. If I do a demo, you have to clap, even if you think it's terrible. Or I will not finish the presentation. Them feel guilty next door that they did not choose this talk. Okay? So those are the rules. So logging disruption. There are 3 variations of this attack that were published by Daniel Grzelak earlier this year that everybody freaked out about. I can't believe they freaked about just turn it off, right? Like stop, because that's a really noisy attack. You can also do things like stop regional logging and global logging. I also think that's kind of boring. My favorite is make CloudTrail operate, but make the logs totally unreadable, so you can't actually do anything with them. So this is your CloudTrail. Like if you think of CloudTrail as the all-seeing eye of Sauron, right?
That looks like a peach. Like,
you can tell he's from Georgia. He's also never seen The Lord of the Rings.
no. I'm so sorry.
So CloudTrail, it sees all the API events, it logs all the events, and it puts them in an S3 bucket. Great, right? Like you can do things with those logs, like detect evil, like with little CloudWatch events and lemmings and things. This is your CloudTrail on crypto. Everything still happens. It still logs all the events. But the events get encrypted with a key that nothing can use besides the attacker. So things don't happen then, like detecting evil. So this basically makes it an exercise in burning money, like in the account as an attacker, because you're encrypting against an encrypt-only key. To create this in the account is moderately difficult from the API. You have to set this flag called bypass policy lockout safety check. Like, why is that even a feature? Like, why can I do this? It does come with a lot of warnings in the Amazon documentation, and that's like a big finger that says, hey, look here, hackers. You can use this to do some cool stuff. So what? This requires a really high level of privilege, but it is really handy if you happen to come across a set of high privilege keys for remaining undetected in the account, and it's also not necessarily undetectable. So has anybody seen this on the internet? Like, this was a big thing, the moon balloon that terrorized people. I would describe this as not normal behavior, right? And I love this, like, lady with the bike, you know, and the moon's coming at her, and she's like, what do I do with my bike? So this disruptive logging creates some not normal markers. So creating encryption keys, if this is not something that you do regularly, is going to get logged prior to somebody performing this attack. Calling update trail on your CloudTrails is probably also not something that you do every day. You don't change your logging settings. So just detecting these two things and being able to sort of bounce back to a known good state for your logging is something that you should be moderately competent at. So I put out a blog article that's part of a series I'm writing called Defense Against the Dark Arts. That's a 4-part series that deconstructs Daniel Grzelak's blogs and proposes defenses. And so there is Lambda code in this blog article that you can just drop into your account, and it will snap your CloudTrail back to a known good state. So this is that CloudWatch event pipeline in action, like as a diagram. So it's like putting little tiny all-seeing eyes on CloudWatch events that look for other things, and they run some Lambda code. So it's really simple. It's just Python. So everything will still happen. So here's a video of that in action, where I'm pretending to be an evil attacker coming in, like turning off logging. I do it with clicking instead of commands, you know, for theatricality. And so I'm doing bad things, like let's pretend bad things, bad things, bad things. I turned off the log. I turned off all regions. Let's count to 10 now. 3, 4, 5, 6, 7, 8, 9, 10. Somewhere in here there's Lambda code firing in the background. And oh my God, it's all put back to the way I think it should be. So you can do this in your account. So now let's talk about really scary stuff. I'm glad you remember the rules, though. So security token service attacks. Security token service attacks are great. I love this because it's exploiting a feature, right? So that's what we do as attackers. We take things that are useful and we weaponize them. So how do these attacks happen? They happen through metadata compromise, like I showed you, as a result of a key compromise, or some credentials leak through an application running in a role. So with the EC2 command line, you can generate these with AWS STS get session token, and you can specify a duration in seconds that that session token will be valid for. I think this can be up to like 72 hours or something. Like, it's a really high number. I might be wrong about that, but it's large. And so these session tokens are an access key, a secret key, and a token, and you can just plop that in a Boto profile, and you can go to town with that token. So you can't revoke temporary STS tokens, which I think really sucks about the IAM dashboard. And without CloudTrail, you have no way to know how many of these tokens have basically been shredded in your account, like by an attacker. And someone can actually come along and use these to like completely end your account. Because if you just do disable access key or something, all those tokens are still valid. So companies have like ceased to be because of attacks like this, where they couldn't recover after all their instances were terminated and all of their account S3 buckets were deleted. So has anybody ever heard of the Codespaces attack? Like 2 other guys have referenced this weekend, so I wish I had a better example, but this is kind of the go-to. So as a company, we all know trust is hard to gain and really easy to lose, and like one breach can, you know, be the in-game scenario. So how do you defend against this? You don't, but there is kind of a way. So just kidding, there is a defense, sort of, which is that you can either deny access to the creator of those tokens, so you can completely remove an account. You can deny access to the name, or my favorite is actually attaching a policy that denies access to any temporary session token issued before a date timestamp. So you can effectively draw a line in the sand and say nothing before this moment is valid anymore. So if you have a breach, that's something that I would just do to every account, is attach this policy. So it looks like this. It's really simple policy, time-based revocation. This is straight out of the Amazon docs. So one and done kind of policy to attach to all roles. And we're going to add this to our CLI for key compromises here very soon. So now that you have this, like go defend your Amazon accounts, like tell other people how to defend against these attacks so we can stop talking about them at conferences. So now we get to my favorite new type of attack, which is backdoors via API gateway. So does anybody use API gateway here for like real business? Okay, a couple. It's relatively new. It's serverless. So that means that Amazon like takes some code and like runs it for you, and you can attach RESTy things to the other side. So people say serverless is the future. I say serverless is the future of attacks. Because these are so new, auditing really hasn't like caught up with serverless tech yet, and you can be really quiet. So we can make backdoors, we can exfiltrate data, we can run a C2 for a botnet, we could run a ransomware backend and lots of other things. And so I made a backdooring tool for API gateway with a serverless framework. Why would I make a backdoor tool? So who said it was once my job to think as dark wizards do? It was Mad-Eye Moody from Harry Potter. And I love this. Like, I love this character because they actually chastise him in the movie for knowing how to do bad things. And I'm like, I have been that guy, like in a business. I'm like, why do you know so much about attacks? So you win a t-shirt. So be sure to come up and grab your t-shirt like that you want now or later. So my backdoor toolkit is called the Mad King. So imagine that you're working at a business. Bad things happen. One of your developers leaked a super privileged access key. You think that you saved the day, like you even clean an account of STS tokens, and then the attackers still end your company. And then you're very sad. And you're thinking, how could they do that? You know, maybe you're moving, quitting your job, packing your bags, who knows? So let's look at how that works. So I use a serverless framework called Zappa. So does anybody use Zappa? It's amazing because you can just like write Django or Flask, and Zappa will shred that into a million little tiny Lambda functions and push it into an account, which I think is great. So you just run one command, Zappa deploy production, and it starts deploying this backdoor into the account. So we already have access at this point, but we want to stay beyond our keys being disabled or STS tokens being revoked, and we want to do that rather quietly, right? So it sets up all the API gateway routes, uploads, some Lambda code and stuff, and then at the end, what you get back is just a URL. It's like, this is your endpoint. So that's not as exciting as the video of it actually working. So this is a web interface now that I can hit at that endpoint. So I put a few simple like POC buttons in this: recon, disrupt, and persist, just so you can model these attacks in your environment. Like you have this for your IR game day or whatever, not to actually end people. So you can see it says running with stolen credentials from, I get the account ID, I can stop instances, I can terminate instances from here. The inventory takes a little bit of a long time to run because it has to query all regions globally. That's kind of the only downside of serverless, is that you don't really have cache without Redis or something.
Yeah, we didn't optimize the attack tool, like if you're attacking.
Yeah, this is like a weekend's worth of API gateway persistence effort. So, but I needed it so that I can profile the attacks so that I can write detection pipelines. So we can stop CloudTrail here, we can delete CloudTrails, and I also added a button that does that, encrypt CloudTrail. So you can practice that in your own environment. This is me obviously being very confused while I'm recording as to what's happened. And so we'll get to the exciting part at the end here, where we actually see that I can generate additional session tokens. So one of the things that people don't seem to audit a lot is that you can have 2 access keys. And if a developer doesn't already have 2 access keys, you can just ask for another one, and it will just spit that out as long as you have appropriate privilege. And so I added this get credential feature, and I made it copy and pasteable. So you can just take that and chunk it into a Boto profile.
The internet is going crazy with those keys.
At any time, you can also decide if it's not going well to click the burn them all button, just like the Mad King, and it will terminate all the instances in the account, like via API Gateway Pivot. So here we see it actually burning them all. So I click the button, like there's a little iterator running in Lambda, and the account is actually just destroying itself. So this is there for you to build your alert pipelines. It is not there for you to do bad things, right? So you throw this in a test environment or something and then like hook up your CloudWatch events and stuff and like revel in the glory of getting these alerts and then sleep well. Yeah, so yeah, do not have the wrong Boto profile at the time, but we did in fact just burn that entire account. So that was my account. All those access keys have been disabled. Don't even bother. You'll just make Amazon really unhappy. So what? That is a really small payload. Like, it's less than like 10 megabytes, I think, in total. It gives you persistence in the account. And there's actually an undeploy function that you can use that will tell it to surgically clean up its own logs. That's like a feature, -- delete logs of Zappa. And it'll just like kind of go extract its own events from CloudTrail and CloudWatch, which I think is great. Most platforms probably aren't auditing serverless yet. So this is like a little bit of an arms race for a while. And there's no such thing as a security group for who can talk to an API gateway. Like, there's no firewall. It's just out there. They rely on API keys to keep you safe. So now we're to the final tips and resources section, which I think is mine. All right, so how do we protect ourselves from this stuff? No less than what I call 3 dumb clouds. Steve Gibson, anybody know Steve Gibson, Security Now podcast guy? He does that great shtick about no less than 3 dumb routers in your home to separate IoT devices from your actual computers. Why wouldn't we do the same thing for our AWS accounts? And instead of running dev, test, production in one cloud, why not have them be separate clouds? So we can have real security boundaries between these. And this actually shows one for consolidated billing. I almost don't count that as a cloud. But maybe we actually need 4 clouds or even 5 clouds. So I think we're going to see the evolution of ops teams and SecOps having security clouds that look outside into your production, into your development, and are saying, is this behavior normal? Am I still receiving logs? And have all of the alerting in that bastion where people don't care about multi-factor authentication because we're security people. Like, we don't mind jumping through all of these hoops just to get into the security cloud. So we love these companies that we showed off their stuff: Netflix, Capital One, Yelp, and Prezi. Prezi's recently started doing this huge collaboration with Netflix, augmenting their stuff. So we should really like applaud them, like, for taking their secret security sauce and putting that out there online. And if you have secret sauce, like, contact us and we'll try and help you put it out online, maybe as part of our project. And we love our contributors. We need users to test our stuff because it's so young. We need you to like break it and file pull requests and tell us that we made bad assumptions about IR if those exist in our tools, which I'm sure that they do somewhere. So please test our stuff and let us know if it applies to you. So if you want more information, we have a mailing list you can subscribe to. We have a future roadmap, which I don't have time to talk about and take questions, so we'll leave that to the internet. Thanks to all these people. Amazon Web Services Security, specifically these guys, have been great and incredibly supportive of our project. DerbyCon staff, Tony De La Fuente, the person who did our slide illustrations, and our team member who couldn't be with us today. And seriously, don't let me forget to take questions at the end of this. Yes, you can use a WAF. It's just not actually part of API Gateway as a service. Yeah. What I can't comment on all of that because I just don't have like all of the information about inside AWS. But what I can tell you is that the security team there that we have worked with has been incredibly receptive to our feedback. So those guys, Don Bailey, who's a principal security architect of AWS, has been like a real advocate for getting more incident response capabilities like into AWS as a whole. Yeah. Yeah, having open source for API endpoints and things like that, or just platform in general. Yeah, we would love to see that, but we haven't had any dialogue at any point with anyone inside Amazon that could even speak to that. Go for it. So right now, our tools need to have a very high level of access. We're working on whittling that down since we're getting better at being IAM policy ninjas, but that stuff does tend to hurt your brain a little bit when you're trying to get down to a point of real least privilege policies. So we're in the process of reducing it right now, but it does need create bucket, list bucket, upload bucket, stop instance, take snapshot. So that's high privilege, I would consider. Any other questions? Thanks, everybody. You guys have been great.